The number of downloads of a new song grows at a continuous exponential rate during the first week after a song's release, as shown in the table. Which function is used to find n of t, the number of downloads after nts? So we got to find a function that would represent this data. And there's a big key up here. It says it's at a continuous exponential rate. And we talked earlier about where you would get these equations from. I'm going to open up the formula chart. And now let's go through to exponential. So it's a continuous exponential model. So I'm going to go over till I find exponential functions. And we learned that continuous is this formula right here. If you're noticing down below it says continuous, that's okay. Both of these are the same formula. N sub 0 just means the initial n value, and this would be the current n value. The same thing here. P means principal or initial value. A would be the final amount. Notice the rest of the equations are exactly the same. R and K represent the rate. T is time. So these formulas are the same. These two formulas are the same. The only difference in compound and exponential growth is that this is happening a certain number of times. So like I said, monthly, that n refers to the number of times per year, or you'd put like a 12 there if it were monthly. This is happening once a year. That's the only difference in these four formulas as you look down. Continuous is on the right, left is a certain amount of times per year. This being once per year, this would be multiple times per year. Okay, so it said continuous, so I'm going to use this formula here, A pert. A equals pert is how I describe it, because that's how it looks. And so let's go up to the table and see what we can label. This is the initial amount. This would be P. Now, if you want to use the formula with N, you could. That other formula that was there, you could use this just fine. If you did so, this would be N sub 0. So let me do this here. Let me get the colors aligned. That's P, or you could call it N sub 0. That's the initial amount. This would be your final amount. So you could say A, or you could just list this as N. This right here is how many times. It's the T. Obviously, T is 7. And so now let's plug in what we have on a formula. And so let's plug in here. We have A, or N. The final amount is the 8,750. Those go in these two spots. N sub 0, this is the starting amount. This is the 800 here and here. E, that's that value in the calculator. It's kind of like pi. It's assigned a value. E is roughly 2.72. It continues on, but that's roughly what it is. So we don't have to substitute for that. And we know that T is now 7. So that's the information we have so far. So what we have to solve for is K to get the equation. So I'm going to rewrite this since we have it written for both formulas, both ones on the right that say continuous. I'm now just going to solve it once on the side because, as I said, they're exactly the same. So we have 8,750 equals 800 times e to the power of k times 7. Now this is most directly how it's like. And if I wanted to solve, I would get e by itself. So the first thing I would do is divide by 800. By the way, if you know your calculator tricks, you could solve this. You could graph to see where they intersect. I'm going to just show you by algebra how you'd solve this. So I'd first have this. And I'm not going to reduce too much yet. I'm just going to, well, no, I will. Let's see here. Calculator 8750 divided by 800. And press enter. It says that is 175 over 16. So I will write that down here. 175 over 16 equals e to the power of 7k. Now, when we talked about exponentials, the way you solve an exponential is you switch it, when you try to solve for the power in the exponential, to logarithms. They're inverses of each other. We said this is kind of like the x value, this is like the y value. So with the inverse, the x and y switch. So when I switch it to a logarithm, a log of a base e, remember, is the same thing as a natural log. When you see ln, that just means it's a log with the base of e. So I'm actually going to write this as ln, which means my base is e. That e is gone right here. And now these two switch, because an inverse switches x and y. So I would have in here in the parentheses that the calculator would give 175 over 16, and that will equal the 7k. Now I'm going to take away this e because the calculator won't show it. It's just a hidden base of e there. And so we'll be one step away. To get k by itself, all I'll have to do then is divide by 7. I cannot divide into this equation because it's into the logarithm, but I will divide the whole logarithm by 7, and this will give us k. So let's go to the calculator and see what it says. Come over here and I say the natural log, control e to the power of x, that's the natural log, that has an in base e there, of 175, whoops, what happened to my formatting there, 175 over 16, and then we divide all of this by 7, like that. Press enter, this is the value of k. So I'm going to just take this over, so I don't have to look back again. Wait for this to appear. There it is. And so now that I have this over here, we can write our equation. So the equation here, now that I know what k is, I'm going to go back over here. You can choose any of these formulas. Since they said what is the value of n of t, I'll write it of n of t. That means the value of the function at any point in time would be, remember how we start with 800, that's the principal amount, 800 e to the power of this, which you could leave this, we'll round this to nearest 1,000. 1,000 has 3 zeros, so I'll go to 3 decimal place. I'm just going to say this is roughly 0.342. So 0.342 times 7, which if I wanted to simplify that, I'm going to do this before rounding it here, times it by 7. And now we will use this value when I write my equation again. Let me just copy this right on top. Okay, so there's the other value. So you could say this, or let's reduce this to n of t equals 800 e to the power of, I'll say 2.392. Whoops, 392. That's when I reduce that. 2.392 is what I'll round that to. And so this will be my answer here. So I don't know how, I don't obviously have the answer choices copied here, but that's how you'd write it. If you, the top would be if you wanted every piece showing the time. Oh, you know what I messed up on? This is in value in terms of t, so this should just be a t here. And so you would not have that value there. So yeah, that would be my answer right there.